This time, let's try to address the very important problem when we try to implement the linear regression algorithm, which is basically called as multicollinearity. Multicollinearity. So I will explain about multicollinearity in this video. Also, in the upcoming videos, we will discuss how to overcome this multicollinearity. Here, we will discuss how to identify the multicollinearity. So for that, let's take a data set. The problem statement here is to build a mathematical relationship between MPG and the other attributes. MPG is nothing but miles per gallon. Okay. So now, is it a supervised machine learning model? Yes. Because the problem statement is to build the relationship between MPG and other attributes, right? So MPG is the dependent variable. Just because there is a dependent variable, it is supervised machine learning model only. Is it regression or classification? It is regression. Because MPG is the dependent variable, which is basically numerical. Right? So let's proceed with that. I have imported all the packages like a NumPy, Pandas, Matplotlib, and a Seaborn. And then I'm just going to implement only the linear regression model. I have loaded the data set. So let me show you how the data set is looking like. MPG, number of cylinders, displacement, horsepower, weight, acceleration, model year, origin. Origin should be basically the place, right? But you can see here as number, car type, as well as car name, right? So this is what we are trying to find out. Y is equal to MPG equal to how many times cylinder plus how many times displacement plus how many times horsepower and so on. So now our car name is not really required, right? So I'm just going to drop this. Now this is how my data set is looking like. So you can see there are 398 rows and 9 columns. As I told you, origin. Origin is basically place, which cannot be considered as a number. So I could see 1, 2, and 3. For example, I'm checking with the data collection team. The data collection team informed that wherever they have mentioned 1, it's America, 2 is Europe, and 3 is Asia. So keeping those points in my mind, I have done this. Okay. Origin, I have replaced 1 with America, 2 with Europe, and 3 with Asia. And then once I did that, you can see it has been replaced. Now it is categorical data. So we are supposed to encode it, right? So for that, I'm going ahead with pd.get_dummies, which is basically one hot encoding. So now people get questions like, Lata, already it was a number. You changed it with America, Europe, and Asia. And once again, why do you do this encoding? You need to understand America, Europe, Asia, or country names. It was just represented randomly like numbers. We know that linear regression is building the mathematical relationship between dependent variable and independent variables, right? So now, whichever is being assigned 3, that could be given more weightage. So randomly people have given 3 for, it could be America or Europe or Asia, right? So we cannot consider that. It may give wrong inference. So when particular column or the unique values are assigned with certain numbers, we are supposed to replace it with the corresponding string values. Then we can go ahead with any kind of encoding, right? So I have chosen one hot encoding. So once I did that, you can see the first data is about America, because America you can see like a true. For example, if you consider this, it fall under Europe, right? This one fall under Europe. So now let me see the descriptive statistics here. So I could see count, mean, standard deviation, minimum, first quartile, second quartile, which is also median, third quartile, as well as maximum. You can see that horsepower column is missing, right? So something is a problem with this Haspar column that we need to identify. So when I try to print D types also Haspar column, we can see like object. But if you see here, Haspar column is looking like a number. So which means that there is something wrong with this Haspar column. So I want to know what is the challenge with this Haspar column. So I am writing a code here to find out whether there is any string in this data. Then I could see that, yes, there are 6 records which is having string values in Haspar column. Let me repeat it. Haspar column should be numerical, but it is represented as string in certain places. That is why it is being shown like a string data type or object data type. If anybody is not able to follow, pause, go back to the video, right? Just go back for 5 to 10 seconds. Once again, if you listen to it, definitely you can understand it. Already I have posted linear regression, R square, and adjusted R square, the practical implementation, also multiple linear regression, right? So if you have missed out those videos, please watch those videos and come back here so that you can understand it better. I'll be giving the links in the description, right? So please subscribe the channel, because I could see that many of you are watching. Around 92% of the people are non-subscribers. Kindly try to motivate us by subscribing the videos, right? Thank you. Thanks in advance. So I could see that those values, like whatever has been false, I was checking with those records in the CSV file. I could see that they have represented few values, those 6 values as question mark. Let me repeat it. Haspar column should be a number, but in some places, in 6 places, it is showing like a string. So when I was trying to check there, I could see that there were few question marks. So what I'm going to do, I have to replace this question marks with a median value. Some people take a decision to drop the data. It is your choice, but generally it is not advisable to replace the missing values, or it is not advisable to replace, it is not advisable to drop the missing value. So I have decided to replace it. So after that, you can see now, first I'm replacing it with a NaN. After that, I'm finding out the median value. Now I'm again not able to find out Haspar. Yes, I could find out here 93.5. So what I can do, I can replace that with like those question marks with this median value. So now if you see the data type, again you can see that it is object. So what I need to do, I need to convert that into float data type. Now if I see the statistics, I would be able to get for Haspar column also. I hope it is clear, right? So let us now try to go ahead with a pair plot to understand about the correlation, right? So now MPG is the dependent variable. You can see here 1, 2, 3. 3 plots are almost looking similar. You can see that, right? So if I see that those are MPG and displacement, MPG and Haspar, MPG and weight, which are looking similar. And I could also get some inference like my plots are almost looking like a curve, right? So experienced data scientists would be definitely able to figure out that instead of fitting it with a straight line, curve could be a right choice for this particular data, right? So in the x-axis, I have considered other than MPG, all the attributes. And again, America, Asia, Europe, if you want, you can consider it. Then you may be thinking that why have you done this encoding, Lata, right? But sometimes for the data visualization purpose, we just encode it, we do data visualization. If it is required, we can use it, right? But I have decided to drop that also on the completely origin column, and MPG should be independent variable. I have given that. I have splitted the data into train and test. You may be thinking like I'm going faster. The reason is these concepts I have covered already. If you have missed that video, please look that and come back. So for others, it should not be boring. right? That's why I'm just going fast. In case if I'm very fast, please write it in the comment. That can definitely be a feedback to me, right? So I have, like a splitted the data into train and test. Train data is 70% and test data is 30%. And I have built my linear regression model. So I'm fitting it with my train data. So now you can see that I got all the slopes. I think you could recollect y is equal to m1x plus m2x2 plus m3x3 up to mnxn plus c is the formula. So this is the slope for cylinder, slope for displacement and so on. And this is the intercept I got. So what does this infer? MPG is equal to 1.86 times cylinder plus 0.010 times displacement minus 0.039 times horsepower until this car type plus or minus 26.69. So let me get the score of my model. I could see that 82% for train data and 84% for the test data. So what is the inference I could get over here? Here I could see that almost now like these few plots are looking similar. So here also I can see that. So I'm getting some doubt that there could be some challenges with the correlation also. So let me show you that how it is actually looking like. So mpg underscore df dot corr. Because we are trying to understand about multicollinearity here, right? Whenever we implement linear regression model, we always want the correlation between dependent and independent should be higher, but the correlation among independent variables to be the least all the time, right? But you can see here, weight and cylinder is higher. Weight and displacement is higher. These are all basically independent variables. Can you see that weight and horsepower? So the correlation between independent variables is higher, which is commonly addressed as multicollinearity issue. How to overcome this? That we will discuss in the next video. In case if you want that video, please write in the comment. Please like the video. Just also you can try to subscribe the video and also try to share it with your friends. Thank you.